Yeah. So good afternoon, students. Am I visible and audible to all of you? And can you see my screen? If you can able to see and hear, just put yes in the chat box. Namita and the other one from Nisamabad. Can you hear me? Is my voice audible to both of you? Yes? Yes, okay. Okay. Hi Nandan, good afternoon. So let's start with the class. Okay. So it's been long time now. We did not have classes for 3 to 4 days. So in the last class, which was held on last Friday, in that we have discussed about the P block elements. That is group 15 we have discussed. So I told you that only 4 topics are included and the remaining topics are deleted in the syllabus. So in that 4 topics, we have discussed the basic concepts and physical properties and chemical properties. So the last fourth topic of group 15 we have to discuss today, right? So that is the anomalous behavior of nitrogen. Now, what is meant by anomalous? Anomalous means unique. Anomalous means unique. So we are going to discuss the unique nature of this hydrogen, which is the first member of group 15. All the first members of the corresponding groups of P block elements, you can see they behave differently. Okay. So it is due to the following reasons. The first reason or the first characteristics of nitrogen is due to its small size. Due to its very small size compared to its group members, nitrogen is behaving differently. Okay. And the second reason is the high electronegativity of nitrogen. So we all know that nitrogen is the third most electronegative element in the whole periodic table, right? So because of its high electronegativity among its group members, it is behaving differently. And the third reason is related with the ionization energy. The ionization energy of nitrogen is very, very high. This is the third property. And the last and fourth property is the absence of d orbital. Since nitrogen is a second period element, it has only s orbital and p orbital. So no d orbitals are there. But for its group members, that is for phosphorus, arsenic, antimony, and bismuth, those elements they will have d orbital. But nitrogen will not have empty d orbital, so the bond formation cannot occur. Okay, because of that, it behaves differently. So these are the very important 4 characteristics of nitrogen for its unique behavior or anomalous behavior. Okay, small size, high electronegativity, high ionization energy, and empty or vacant d orbital. Got it? So now some more properties are there. So the next property is the nitrogen is having beaker catenation property. We all know what is catenation, right? So ability to form chain of bond with itself and with the other element is called as catenation. So we all know carbon is having that property, but nitrogen is also having that property, but the property's effect is very weak. Okay. So why it is very weak? You can see nitrogen and nitrogen bond. Nitrogen is forming a bond with the another nitrogen. So in this, you can see the 2 lone pairs on each nitrogen. One lone pair on one nitrogen. So there are 2 lone pairs. So because of that lone pair repulsion occurs. Since the size of the nitrogen atom is very, very small, the lone pair, they are very closer to each other. Lone pair of electrons, they try to repel each other. Because of this repulsion, since the length is very small, bond length is very small, and they are very closer to each other, repulsion is very large. Because of that, nitrogen, that bond strength will decrease. Okay, because of the higher inter-electronic repulsion, which is nothing but the lone pair repulsion, because of its high repulsive property, the single bond between the nitrogen and nitrogen is very, very weak. Single bond will be very, very weak. So that's why we are saying that it is having a very weaker catenation property. Okay, usually while studying the catenation property for carbon, we study in accordance with the bond strength only, right? Since the carbon sigma bond is very, very strong, it is having a very strong catenation property and all, we used to study. But because of this inter-electronic repulsion, the bond is getting weak. They are trying to keep them very far apart. So because of this repulsion, the bond is getting loosened and it is getting weak. So the catenation property is very weak. Clear? Now, comparing this nitrogen with its group member phosphorus, so phosphorus is little bit bigger than nitrogen, right? So now the electron, lone pair repulsion, that will be observed very less only, because you can see the strength, the bond length is very high because of its big size. Okay, now the repulsion is very less. So the bond strength, the single bond strength of phosphorus is greater than nitrogen. Okay, and the next property, or I can say the sixth anomalous behavior of nitrogen is the inability to form d pi p pi multiple bond. A d orbital and a p orbital, if they are overlapping in a sideways manner, they are forming that d pi p pi bonds, right? So that kind of nature is not, that bonding is not possible for nitrogen because it doesn't have d orbital, right? But phosphorus can form this d pi p pi bond. You can see here. So phosphorus is having 5 bonds around it. Phosphorus is having 5 bonds around. Phosphorus P double bond is there, and 3 single bonds are there with alkyl groups. So here the double bond is formed because of the empty d orbital which is there in phosphorus. But this kind of structure or this kind of bonding is not possible for nitrogen because it doesn't have a d orbital. Okay, so among these two bonds, one is sigma bond and the other one is pi bond. So this pi bond is formed by the overlapping of the d orbital of phosphorus and the p orbital of oxygen. So this sideways overlapping leads to the d pi p pi bond of phosphorus. Okay, but it is absent in case of nitrogen. Phosphorus, arsenic, they can form d pi bond also, because arsenic is also having d orbital. Phosphorus is also having d orbital, so they can form d pi bond. And with the transition metal acting as ligand such as triethyl phosphine and triethyl arsenide. So this kind of structure is also possible with the transition metal, that is D block metal. Okay. So what is the first property? First is the small size, high electronegativity, high ionization energy, absence of d orbital. The next is weak catenation property due to lone pair repulsion and inability to form d pi p pi multiple bond because of the absence of d orbital. Okay. Any doubts so far from the concept? Any doubt? You 12th class students will not open your mouth at all. Huh? Okay, fine. So the next property is the ability to form p pi p pi bond. Only d pi p pi is not possible, but p pi p pi is possible for nitrogen. So you can see from the given diagram. So here is the nitrogen. Nitrogen is having 3 p orbital. One is px. Let me take this yellow color orbital as px, and this is py, and this is pz. Okay. So among these 3 orbital, the px orbital is overlapping in a sideways in a head-on manner with the other nitrogen to form the sigma bond. Okay. Now the blue color orbitals, they are overlapping with other nitrogen in a sideways manner. You can see here. They are overlapping in a sideways manner to form the pi bond. Okay. Now I'll show you the picture which contains both sigma and pi. You can see, right? So head-on overlapping leads to sigma bond, and the sideways overlapping leads to pi bond. So the sideways overlapping, which is leading to the formation of pi bond, is because of the overlapping of p orbital on both the nitrogen. So it is called as p pi multiple bond. And as we go down the group, the size of the orbital becomes more diffused. The size of the orbital becomes more diffused. Okay. So you can see the size of the orbital becomes big. Okay. So what happens? The overlapping area is becoming very less. So in case of nitrogen, you see the overlapping area is more because the orbital size is very small. So overlapping is small. So it leads to a strong overlapping. But in case of phosphorus, you see, since because of the more diffused p orbital of phosphorus, the overlapping area is very less. If the overlapping area is very less, then the interaction is very less. It means weak overlapping. Got it? So nitrogen can form p pi multiple bond in which that multiple bond is very strong. Pi bond is very strong compared to the sigma bond. Got it? In case of nitrogen. Now I'll show you one question. Yeah. Why does R3P double bond O exist but R3N double bond O does not? If R is the alkyl. The answer is already told to you. Can anyone give me the answer? Why the phosphorus compound exists but nitrogen compound does not exist? Okay. For nitrogen, we have only S and P orbital, no D orbital, right? So the lone pair is there, and it can be used to form the bond with the hydrogen atom. This is what it can do at maximum. Okay. So maximum nitrogen can form only 4 bonds. But in this compound, you see nitrogen is having 5 bonds. So that's why it is not possible. But phosphorus is having empty d orbital also. So what this phosphorus can do? Phosphorus has d orbital, which can accommodate some more electrons. So it can form more than 4 bonds. So from outside, one oxygen is coming and forming the bond with this phosphorus to give R3P double bond O. Okay, to give this structure. So that's why it is forming 5 bonds. Clear? So absence of d orbital is the reason for this question. Now, with this, group 15 gets over. The compounds of group 15 that is not included in your syllabus from this year onwards. Okay. So let me summarize the group 15 for you. Very small summary only. First, we have studied the general electronic configuration NS2 NP3, and these are the elements and its atomic number with the with the atomic radius in picometer. And if atomic radius increases, ionization energy decrease, right? So inversely proportional. And electronegativity also decrease. Okay. Metallic nature increase. Atomic radius and metallic nature, they are directly proportional. Remaining thing are inversely proportional. Boiling point also increases because mass increases, no? So it boils very late. So boiling point also increases. Stability of the +5 oxidation state decreases. I told you, right? Under the inert pair effect topic, we have studied this. Stability of the higher oxidation state decreases on moving down the group. Stability of lower oxidation state only increases on moving down the group. So it was explained by the inert effect. So these are all the general properties I have discussed with you. And coming to the oxidation state, so these 3 plus -3 +3 +5 are the common oxidation state of this group 15. And coming to the reaction with hydrogen, they form hydrides of type EH3. And coming to oxygen, they form 2 different types of oxides of the given formula. And then the next is the reaction with halogen. And with halogen also, they are forming 2 different types, right? One is EX3 and the other one is EX5. This is the general chemical properties of your group 15. Got it? Now, let us try to solve some questions. Let us try to solve some questions from this group 15 After solving some questions, I will move on to group 16. So the question is to you on the screen. Now you guys have to tell me the answer for this. The correct order of nitrogen compounds in its decreasing order of oxidation states is. The 4 compounds are given, 4 options are given, and only 4 compound is repeating in all the 4 options. Find out the decreasing order of oxidation. From higher oxidation state to lower oxidation state of nitrogen, you have to find out. So try to find out the oxidation state of nitrogen in all the 4 compounds. And let me know the answer in the chat box soon. Very fast. Only 30 seconds. 30 seconds is enough to solve this question. Has anyone solved? Has anyone got the answer? Has anyone got the answer? So what is the oxidation state of nitrogen in HNO3? In HNO3, nitrogen is taken as X, H is +1, and for each oxygen it is -2. So 3 into -2 -6. So X is equal to 6 minus 1, which is +5. Okay. And for NO, X minus 2, 0, X is equal to +2. Right. And for N2, it is 0, X is equal to 0. So no electronegativity difference. So it is 0. And for NH4Cl, if the nitrogen is taken as X, 4 hydrogen, so +4, 1 chlorine, it is -1, right? For halogens, the charge is -1. Charge is -1 and X is -4 + 1. So it will be -3. So decreasing means higher number, bigger number to smaller number. So +5 is bigger, then your +2, then comes 0, then comes -3. So this is the correct decreasing order of oxidation state. So which is the correct answer, student? Option A is the correct answer, no? Option A is the correct answer for this question. Okay. So I'll move on to next question. Which of the following statements is not correct for nitrogen? Which is not correct for nitrogen? So you can answer this question from by recalling the anomalous property of nitrogen that we have discussed now. Try for it. Which is incorrect for nitrogen? So in the anomalous property, I told you that nitrogen is having high electronegativity. So that is correct. And in option B, d orbitals are available for bonding. No, that is incorrect, right? So nitrogen is not having d orbital. It is unavailable. So that is the incorrect statement, which is the correct answer for this question. It is a typical non-metal only. Nitrogen is basically a gas. So it is a non-metal and its size is also very small that we have seen under anomalous property. So option A, C and D. These 3 statements are correct for nitrogen. The only incorrect statement is option B. Okay. Now coming to next question. Of the following hydrides, which one has? It is actually hydrides. It is D. Okay. Of the following hydrides, which one has the lowest boiling point? Which one has the lowest boiling point? Nitrogen is there. Nitrogen NH3 is having the highest boiling point due to hydrogen bonding. So you can leave that. Among A, B and C, you try to find out the answer. Which one has the least boiling point? Phosphorus, nitrogen, phosphorus, arsenic, antimony and bismuth, right? So bismuth hydride is not given to you, so I can leave. I told you to leave NH3 also. It is having the highest value. Now among these 3, on moving down the group, the van der Waals interaction increases. If the van der Waals interaction increases, boiling point also increases. For antimony hydride, van der Waals interaction is more. So boiling point is also more. So the least among the given 4 option is the hydride of phosphorus, that is PH3. Okay. Due to the very less van der Waals interaction, the pH3 is having the 12. Okay, so the answer is pH3. Answer is pH3. Okay, coming to, so all these things we have already discussed in the class. All these are previous year's question only. So we have already discussed these topics in the class. Just go through that. So one more question for you. Which of the following does not exist? Which of the following does not exist? So by looking at the options, we can get the answer so easily just by looking. You don't have to think for it. Answer is option A. Answer is option A. Why? Because nitrogen can form only 3 bonds, maximum 4. But in option A, you see it is having 5 bonds with chlorine. So that is not possible. So that compound doesn't exist. Okay. So that's all the for group 15. Now coming to group 16. Now coming to group 16. So concepts about group 16. So we are going to see again the 4 topics here in this group 16. So first is the basic concept, then is the physical property, chemical property, and anomalous behavior of oxygen. Okay, now coming to the first topic, that is the basic concepts of group 16 elements. So let me show you the elements first. It is oxygen, which is a non-metal, then your sulfur, which is a non-metal, selenium, metalloid, tellurium, metalloid, polonium is a metal. Okay, so the first 2 are non-metal, the second 2 is a metalloid, and this is a metal. Got it? Yeah. So we are discussing the oxygen group basic concepts. So these 5 elements are the elements of group 16, that is oxygen group members. Oxygen, sulfur, selenium, tellurium, and polonium. Okay. The general electronic configuration of group 16 elements is Ns2Np4. In s orbital, we have 2 electron, and in p orbital, we used to have 4 electron. And these group 16 elements are otherwise called as chalcogens. They are also called as chalcogens. It is a special name for this group members. So it is also called as chalcogens. Now next I will move on to the occurrence of group 16 elements. So let me start from the first, that is oxygen. So we all know that oxygen occupies the 21% by volume of the atmosphere. Okay. And about 46.6% by the mass of earth crust. Okay. And it is one of the most abundant of all the elements, right? Oxygen is one of the most abundant element of all elements. Got it? So this is the occurrence of oxygen. Then coming to the occurrence of sulfur, present in the ores. In what type of ores? In sulfate. They are present in sulfates. In the form of sulfate, it is present in gypsum, calcium sulfate, calcium 2 plus, SO4 2 minus. SO4 2 minus compounds are called as sulfates. So it is present as calcium sulfate in gypsum, and it is present as magnesium sulfate in Epsom salt with the 7H2O molecule, and it is present as barium sulfate in barite. So these gypsum, Epsom salt, and barite, these 3 are the ores. Okay. Now in the earth crust also sulfur is present, but only very, very less amount. That is 0.03 to 0.1% of sulfur is there in earth crust also. Okay. This is the sulfate story of sulfur. Not only in sulfate, in sulfides also sulfur is there. Okay. Sulfate means SO4 2 minus containing compounds. Sulfide means S2 minus containing compound. Okay. In lead sulfide, galena, you see, galena is called as lead sulfide, PbS. Here Pb2 plus and S2 minus ion is there. So it is present as sulfide in galena, And in zinc blend, in zinc sulfide also it is present, sulfur is present. And in copper pyrite also, sulfide is present. Sulfur is present in the form of sulfide. Okay. And hydrogen sulfide, you all know. In volcanoes, we can find this hydrogen sulfide, right? So here also it is present in the form of sulfide. 2H plus and S2 minus. Got it? So this is about the sulfide story. Then sulfur is also present in organic materials. What are the organic material, natural materials? In wools, in wool you can see, in garlic you can find the sulfur, and in some mustard seeds you can find out, and in onion is also there, and in the egg yolk you can find the sulfur, and in hair it is also present. Sulfide linkage is there in hairs also. Okay. It is also found in proteins. Sulfur is also found in proteins. So sulfur is present in the form of sulfate, sulfide, and in organic materials. Okay. So oxygen occurrence, sulfur occurrence got over. Now coming to the next element, selenium and tellurium. Selenium is present in sulfide ore. Selenium is present in sulfide ore, that is copper tin sulfide, and tellurium is also present in telluride sulfide ore. Tellurium and sulfur containing ore. Okay. So these two are the existence or the occurrence of selenium and tellurium containing system. And the last compound of this, last element of this group is polonium. Okay, it is a very, what to say, it is a radioactive element basically. It occurs as a decay product of thorium and uranium. This thorium and uranium are F block elements. So if these thorium and uranium undergoes this decay process, they are giving this polonium. Okay, and one more element, sixth element we have here in this group 16, which is called as livermorium. Livermorium is the sixth element, last element of group 16, which belongs to the seventh period. And the symbol for livermorium is Lv, and its atomic mass is 292. Okay, its atomic mass is 292 gram per mole. And the atomic number is 116. Belongs to 16th group. It is having, you see, 7s2 and 7p4 configuration, seventh period. And it's since this livermorium is a radioactive element, half-life is got it. Now coming to the next topic. So the basic concepts and occurrence got over. Now coming to the next property, which is the physical properties of group 16. The first physical property is about the electronic configuration. Okay, I already told you that the general configuration is NS2NP4 for this group, and specifically for oxygen it is 2s2 2p4, because oxygen belongs to the second period, and sulfur it is 3s2 3p4. Like this it goes on. But when you come to selenium, d orbital also come into existence, and for tellurium also the same thing. For polonium, f orbital and d orbital both are coming here. Oxygen doesn't have d orbital. Sulfur will have d orbital, but it is empty. But the remaining three elements, they have filled inner d orbitals. Okay. So oxygen doesn't have d orbital. Sulfur has d orbital, but it is vacant. It is empty. Like phosphorus, it is empty. Okay. And the remaining three elements are having the filled inner d orbitals. Okay. So this is about the electronic configuration, the same like group 15 only. So I will jump to physical properties and the trends in physical properties of group 16. Okay. So it follows the same order of with the group 15 only. So you don't have to stress on more, you don't have to put more stress on this, okay, to study separately. You can just follow the same trend. So first is the atomic and ionic radii. So you all know that the atomic radius increases on moving down the group. That is a general trend. The same is the case with group 16 also, because the number of shells increases. If the number of shells increases, atomic size also increases. But the difference between oxygen and sulfur, if you see, it is very, very large. Oxygen and sulfur difference, if you see, it is very large because of the very small size of oxygen. It is exceptionally having very small radius, like nitrogen. Okay. So this is about the atomic radius and its trend on moving down the group. Then coming to the next property, which is ionization energy. So here is the ionization energy values to you on the screen. You can find, or you can able to observe the trend of ionization energy. It decreasing, right? So if size increases, ionization energy decreases because both are inversely proportional. If atomic radius increases, ionization energy decreases because the attraction between the nucleus and valence electron decreases on moving down the group. Okay. Now, as usual, if we are comparing two ionization energy, if I'm comparing the first ionization energy with the second ionization energy, the energy required to remove the second electron is more than the energy required to remove the first electron, right? So the same is the case with this also. Okay. Second ionization energy is very, very high compared to the first ionization energy. So what is the reason for this? Why the second ionization energy is very, very high for group 16 elements? Can anyone answer for this question? Why the second ionization energy value is very high for group 16? It is, so the configuration is NS2 and NP4, right? So if I am removing this electron by giving delta H1, what type of configuration I will get? I will get NS2 and I will get NP3, right? Now this is half filled. The energy required to remove the second electron is very, very high because it is in the half filled configuration, which is stable. So that's why the energy required to remove the second electron, or the second ionization energy value for group 16 elements, they are very, very high due to the extra stable half filled configuration of group 15 elements, which require the extra energy to remove the electron, like group 15. Okay. So this is the reason, the stability of half filled reason. Now coming to the third property, which is the electron gain enthalpy. So what is electron gain enthalpy? The amount of energy released from an atom on addition of electron to it, right? That is electron gain enthalpy. So you can see it is actually decreasing. You don't have to look for the negative sign. The negative sign denotes that the reaction is exothermic. Electron gain enthalpy is actually an exothermic process. Energy is released, from the atom. So for all exothermic reactions, we used to give the negative sign. So that negative symbol denotes the exothermic property. So you don't have to look for it. So just see the numbers alone. So the numbers, if you can see, with the exception to sulfur, for the remaining elements, the values are decreasing. So atomic size is again inversely proportional to electron gain enthalpy. If the atomic size increases, attraction decreases. Attraction between the nucleus and the valence electron decreases. So electron gain enthalpy also decreases. But for sulfur and oxygen, it is an exception because oxygen is very small in size. Oxygen is very, very small. This is oxygen. This is the nucleus of oxygen. This is oxygen. It is very, very small. If I want to add one electron to this oxygen from outside, I have to spend more energy. I have to spend more energy to add the electron. That's why you can see the value. It is very less negative. Actually, the electron gain enthalpy value should be more negative for an atom. If the electron gain enthalpy value is more negative for a species, then it says that we can easily add an electron to that species. Got it? But here it is less negative compared to sulfur. So it is because of the small size of oxygen. We need to spend more energy to add the electron, okay, which causes the repulsion. Now it is larger than group 15 due to the small size of group 16 element, okay. Across the period, ionization energy increases. So when you compare group 15 and group 16 will have the highest value. That's what they are coming to say. Got it? Now coming to the fourth physical property, which is the electronegativity. Electronegativity is the tendency to attract the shared pair of electrons towards itself, right? So that electronegativity values you can see on the screen for all the 5 elements. So it is also inversely proportional to the atomic size. If the atomic radius increases, attraction decreases. Electronegativity also decreases. So oxygen is the second most electronegative element in the periodic table. Fluorine is the first most, and its electronegative value will be 4.0. The second most is oxygen, which belongs to group 16, and it has, you can see, it is having 3.5. Okay, so this value decreases on moving down the group, but it is greater than group 15. Across the on moving down the group, electronegativity decreases. Across the period, electronegativity increases. So when you compare group 16 with the group 15, obviously group 16 elements are going to have the highest electronegative value. Okay. Then the next is the boiling point and melting point. You can see the trend. It is following some irregular trend, right? So from oxygen to sulfur, it is increasing. Till tellurium, it is increasing. Melting point is increasing. Boiling point is also increasing. But when you come to polonium, suddenly a decrease occurs. So when atomic radius and atomic mass increases, boiling point should increase. Okay, melting point also should increase. For oxygen and sulfur, the difference is very large. Some around 200 difference is there, no? Difference is very, very large. Okay. It is due to the form. It is its existence. Oxygen is existing as O2 and sulfur is existing as S8. So in sulfur, 8 atoms are there, and in oxygen only 2 atoms. So melting point and boiling point is they depend on the mass, right? Molecular mass. If more number of atoms are present, the mass will be more. The molecular mass will be more. Then the melting point and boiling point will be very, very high. So that's why the difference is very high because of its allotropic form. Sulfur cannot exist in S2 form. It exists only in S8 form. So that's why a big difference is observed. Got it? I hope till this topic is clear to you. Then coming to the metallic and non-metallic character, the first two elements are non-metal. This we have already seen in the first slide, no? Oxygen and sulfur are non-metal. Selenium and tellurium, they are metalloid, which is otherwise called as semi-metal. And the last polonium is the only metal in this group. So as atomic radius increases, ionization energy decreases, metallic character increases. Metallic character increase. These are all the general trend for all the group elements. Okay. So this is about the physical properties of group 16. Atomic size, ionization energy, metallic nature, boiling point, melting point, electron gain enthalpy, and electronegativity. So these are the 6 general properties you're going to concentrate under physical property. So any doubt from the 6 physical property that I have discussed? Do any of you have any doubt? Open your mouth and give me the answer in the chat box. Give me the response. If the physical properties are clear to all of you, just give a thumbs up or type yes in the chat box. Sandeep, when did you join? Are you all listening, the class students, my dear class 12 students? Are you all listening? Can anyone reply me? Naina, Bindu, Nandan, Sandeep, Sujan, Hemant, and Namita. All of you can hear me, right? Yes. Is the concept clear to all of you? Shall I move on to the chemical properties of group 16 elements? Any doubt any of you have? No doubt? Okay. So moving on to the chemical properties of group 16 elements, the first is again the oxidation state. The common oxidation state of this group is +4 and +6. So like in the previous group, we have seen +3 and +5, right? So here it is +4 and +6. You can see +4, +6 is occurring in most of the elements. But for oxygen, +2 state exists only for OF2. When oxygen is present in the form of OF2, in that OF2 only oxygen will take +2 state. This you might have studied in your redox reaction lesson of your class 11. Oxygen is bonded with the most electronegative element in this compound, right? So it will lose its electron. It will lose 2 electron to form the 2 bonds with OF2. So only when oxygen is bonded with fluorine, it takes positive oxidation state. So here it loses 1 electron, it loses 1 electron, and with respect to this bond, oxygen loses 1 more electron. So here, if you can see, the oxidation state will be +2. Okay. And +4 oxidation state with oxygen and +6 oxidation state with fluorine. So when sulfur, selenium, and tellurium, when these 3 elements are forming the bond with oxygen, they form +4 state, and if they are forming the bond with fluorine, they can have oxidation state up to +6. Okay. Then talking about the covalency, maximum covalency of oxygen. Like we have seen, no, the maximum covalency of nitrogen is 4, right? So like that for oxygen, it is 3. Oxygen can form only 3 bonds. Maximum it can form only 3 bonds. Like in case of H3O plus, you might have seen. So here you can see that oxygen is having 3 bonds. This is H3O plus. Maximum covalency is 3 for oxygen. And coming to the stability of the lower oxidation state, stability of -2, you see, it is decreasing. But the stability of +6 is also decreasing. Polonium is not having -2 or +6. But the stability of +4 is increasing. Stability of +4 is increasing for group 16. So the bonding in +4 and +6 oxidation state is primarily a covalent compound. So when you find group 16 elements with +4 and +6 oxidation state in it, then you can tell that the given compound is covalent in nature. Okay. So why the stability of lower oxidation state increases on moving down the group? So why +4 is more stable for polonium but not +6? So what is the reason for the stability of lower oxidation state? The same reason, due to inert pair effect. It is due to the inert pair effect. I already told you what is inert pair effect, right? The reluctance of S electron to take part in bonding due to the attraction towards the nucleus is called as inert pair effect. So because the shell number increases and the addition of D and F electron increases for selenium, tellurium and polonium. But this D electron and F electron, they doesn't shield the inner electrons properly. Sorry, the outer electron properly. They are the very poor shielders of valence electron. They will not shield the valence electron properly to the nucleus. So because of this, the S electron is getting attracted towards the nucleus which is there in the outermost shell, and it cannot take part in the bonding. And only the 4 electrons which is there in NP4, in p orbital, they can take part in bonding. Okay. So the stability of the higher oxidation state, that is +6, decreases, and the stability of lower oxidation state +4 increases. Got it? Same reason. Now coming to the reactions of group 16. Reactions of group 16. Again, group 16 elements reacts with hydrogen, it reacts with oxygen, it reacts with halogen. So these 3 reactions are possible for this particular group also, like group 15. Now coming to the first reaction, that is a reaction with hydrogen. So here, when group 16 elements are combined with hydrogen, they are forming the hydrides of formula H2E, H2O, H2S, H2SC, like that. Okay, they are forming hydrides of formula H2EE is the 16th group elements. Now, what is the stability? In group 15 also we have studied this stability, the same stability we are going to see here also. For the first element, that is for oxygen, you can see 2p orbital is overlapping with 1s of hydrogen. In case of sulfur, 3p orbital overlaps with the 1s of hydrogen. And for selenium, 4p. For tellurium, 5p. Okay, so you can see the overlapping area decreases as the size of the orbital increases. So what is the overlapping order? 2p oneness overlapping is very more high compared to others. So this particular 2p oneness, they will form very strong bond. The energy required to break this bond is highly difficult. So the energy required to break the bond is nothing but the bond dissociation energy or bond energy. So for H2O, it is very, very high. So it decreases on moving down the group. Okay. So the bond dissociation enthalpy order is as follows due to the high bond strength and thermal stability order also. So again, H2O is highly thermally stable. When you heat it, it can withhold the high temperature. H2O can withhold the high temperature. So it is thermally stable. Okay, thermal stability and bond dissociation enthalpy order both are same for the hydrides of group 16. Okay, now let me discuss the reducing nature. This is actually group 16. Okay, group 16. So the reducing and acidic character of hydrides. So what is reducing? The removal of hydrogen, right? So you can see from the diagrams that the bond length between the group 16 element and hydrogen, it is increasing because the size of the element increases, bond length also increases. If the bond length increases, it follows this order. So hydrogen can come out easily from polonium. The bond can be broken down so easily. So that can gives out the hydrogen so easily. So the polonium hydride is having the highest reducing nature. That's all. H2O will not reduce at all. From H2O, you cannot take out the hydrogen at all. So OH bond is very, very strong. It cannot be broken down so easily. So H2O will not have the reducing property. No reducing property for H2O. Got it? And since the polonium is able to form or polonium is able to give out its hydrogen so easily as H plus, that is having the highest acidic character also. The compound which gives out the H plus easily is called as an acid, right? Complete dissociation of H plus is called as acids. So polonium is giving out hydrogen easily. So again, the polonium hydride is most acidic in nature. So the bond length, reducing nature, acidic nature. So these three properties are following the same order. Got it? So the bond dissociation energy and what is the last one? Thermal stability. Those two followed some order. So these three are following just the opposite of that order. Clear? Clear for all? So the next is the reaction with oxygen. So it's already time. You have to go for the next class, right? It is 4:55. So the reaction with oxygen, I will discuss in the next class. Okay. So if you're having any doubt, you can ask me. Okay. Otherwise, you go home and study the concepts which we have studied today. So what are the topics we have covered in group 15? In group 15, I have taught the anomalous properties of group 15, and in group 16 we have discussed the basic concepts and the physical properties and its strengths, and under physical property we have discussed some 6 points. Okay, atomic size, ionization energy, electron gain enthalpy, electronegativity, and the metallic nature. Okay, these are all the topics we have discussed. What is the other one? What is the sixth topic? We have discussed electronegativity, yeah, boiling point and melting point. Okay, these are the 6 physical properties we have discussed there. And coming to the third property, that is the chemical property. And in chemical property, I have discussed the oxidation state. Then the reaction with hydrogen we have discussed. Got it? The reaction with oxygen and reaction with the halogen we will discuss tomorrow. And after that, we will move on to the anomalous property of oxygen. And after that, we will go on to the group 17 elements. Okay. So try to join on time tomorrow. Okay. Try to join on time. So on Sunday and Saturday, Sunday we will, not on Saturday, we will have question discussion session on Sunday. Okay, 12 p.m. we will have. So from this lesson, we will try to solve questions on Sunday. Got it? So, okay, then no doubt for you guys. If you don't have any doubt, then you can leave the class. Thank you so much for listening to today's lecture, students. Thank you so much. Bye-bye. Take care.